is the third in the shape and space series, and we're looking at volume and surface area. So this involves 3D shapes that we're going to be looking at. So in this session, what I want to try and do is look at how we work out volume and surface area of key shapes. I'm particularly talking squares and rectangles, circles and triangles, and you'll see I'll mention why about other shapes in a little while. Following given formulas, and some I'm going to give you that you have to learn. So those who were on the circle and triangle one earlier, there were some formulas to remember from that. And unfortunately, there's one more formula I am going to give you, well, a couple of formulas here I'm going to give you that you are expected to remember. And we'll work through some practice questions again, and we'll work through them together. One thing I'm not able to do is share my calculator on screen. So what I would suggest is, if when we're working things out, if you want to try your calculator, I'll have mine on screen, but it won't share very well. So if you've got a calculator or pen and paper to work through as well, then you're very welcome to. So as I always do, just have a think about how confident you feel about working with 3D shapes. If you were asked to work out the volume of a cylinder or the surface area of a triangle, of a prism, something like that, how confident would you be on that? If I do that question at you now, 1 to 10, 1 being lowest, 10 being highest. And don't worry, if you're really confident, that's great. You're welcome to do some revision. If you're not confident, that's what we're here for. So, looking, I think there are generally probably lower scores than we had earlier, which makes sense because we went from the basics, which should be, as it says, the base understanding, which some people are quite confident to start with. Circles and triangles are a bit more tricky, but are okay. And now we're getting up to the volume and 3D shapes, the surface areas. It does become more difficult. Right. So I mentioned earlier perimeter and area we did mainly, and then volume is this sort of third aspect that we're doing. So perimeter and area are on flat shapes. The perimeter is an outside of a shape. So if you've got a flat shape, example I gave you earlier, if you were looking at your garden, you want to put a border all the way around it, you've got a flat shape there, you walk around that border and you get perimeter. If you want to know what grass to put down, you need to know what area it covers, or maybe the surface area. So just if you imagine a flat shape, that's what you work out. Volume is more 3D shapes. So if you're filling a sand pit or filling a swimming pool or filling a tin container or something, and so that there are more calculations that are needed in there, and it's a little bit more difficult, a little bit more detailed, which why we'll go through it. Before we start, I just want to mention one thing, difference between volume and capacity. So sometimes you'll see the word volume and sometimes you'll see the word capacity, and they are pretty much interchangeable for most time. There is a difference between them. This glass on the left has nothing in it, but it still has this much capacity. This is how much you could put in there. The glass in the middle, this is the volume that's in it, and you see it says half full or half empty, depending on your outlook at life. But actually, it still has the same capacity because we could put more in there. And again, the third one has the full capacity, and the volume is all the way up as well. So volume tends to be what we've got inside something. Capacity is how much it can hold. But actually, quite often they'll be interchangeable. So if somebody said, what is the volume of a can of beans? Then whether the beans are in it or not, we talk about the volume in there. But if you did need to distinguish between them, that's the distinguishing. Or if you see the word capacity and a bit unsure, but that's the key thing about them. If you think of a fish tank, for example, you wouldn't fill it right to the top because the fish might be able to jump out. So the volume would be a little bit lower than the capacity. But as I say, they generally are used interchangeably. Thinking about the functional skills test, which is what you're here for. Volume definitely does come up in there, and you are expected to know how to work out volume and surface area. And it says sometimes you'll be given a formula, a bit like I said with circles and triangles earlier. You may be given the formula, but you are expected to know certain formulas and how to work them out. And one of the things that's key is, even if you're given the formula, if you've never seen it before, it can sometimes be a bit awkward to work through it. So it's useful to know the formulas and know the way to work them. The other thing I'll say is there are complicated formulas that can be written down. And if, again, functional skills is equivalent of a GCSE, and sometimes people say, what's the difference? Well, if it was a GCSE, you would probably be expected to list the formula, note the formula down, and then follow it. For functional skills, the whole point of it is it's functioning. So if you can get the answer because you remember a certain way to do it that maybe isn't quite the strict formula, or you're having to take your shoes and socks off and use fingers and toes, as long as you get to the answer, that's fine. And that's what we do in everyday life with maths. We may not know the formula for working out things, but if we know how to do it, that's the key thing. So I'm going to give you my way of doing things that may not be the most technical formulas in the world, but hopefully will help you work them out. But if you do see a more technical formula, or if you know one and you want to follow it, you're very welcome to. So the way I suggest people work out volume is to work out area, which we did earlier in the 2 sessions, and then times it by your third dimension. And what I'll do is I'll work some examples for the different shapes and we'll see what we mean. So I gave the example of a fish tank earlier. We'll assume, forget about the volume capacity thing and just talk about, we're talking about how much water could you have in that fish tank. Just so I could label it, we'll just change it for a nice cube like that. And if we had some measurements for this, so we're going to have the measurement across the bottom is 1.8 meters, along the side is 90 centimeters, and up the side at the back is 1.1 meters. Again, I've mentioned in previous sessions that I don't tend to use words like length, width, and depth. So looking at this, the width will be 1.8, our height would be 1.1, and our depth would be 90. But if I turned it round, I'd have different measurements in different ways. So actually, I'm talking about the 3 dimensions. In one way, it goes 1.8 meters, one is 90 centimeters, one is 1.1 meters. So the way I would suggest working out volume for this kind of shape is if you work out the area of a flat shape first, then we'll work turns into the 3rd dimension. So I'll show you what I mean. Before we do that though, you may have noticed that I've purposely done one measurement in meters, this measurement's in meters, but this one's in centimeters. And one of the key rules you do need to remember when you're doing any kind of perimeter volume area, I mentioned it earlier as well, is you need to have the same measurements. If we do the calculations with these measurements, then they're going to be awkward because we've got centimeters and meters. So what we do need to get them all the same. We could turn them all to centimeters, which would be absolutely fine, but actually it seems silly because we've got 2 meters already. So why change them to centimeters when we've already got this one? And you might know there's 100 centimeters in a meter. So if I just divided that by 100, then 90 centimeters is the same as 0.9 meters. So that's what I'm going to use. So that's one of the first things to look at, is check that your measurement's correct. I gave the example earlier, this is in meters, but if you wanted the answer in feet or inches, then you would need to do those conversions before you do any calculations. Is a lot easier. So always get to your, whatever your final measurements are in, get to those first before you do your calculations. So what I'm going to suggest now is working out the surface area or the area of this front bit, this yellow bit, which you imagine is it's fish tank, it's the front screen of it. If you remember from earlier, I said the way to work out area is multiply one side by the other. Well, that yellow screen is 1.8 meters times 1 meters. And if you've got a calculator and you want to do that, I'm going to open mine. I'll do 1.8 times 1.1. I know you can't see that on your screen. But that comes to 1.98 meters. And we've just worked out area of the front side, and it's 2 squared, sorry. So 1.98 meters squared. That's great, and so that's a flat surface. What we want to do now is work out how much is the volume of the whole fish tank. And if you think about looking at that fish tank, we've got the front screen, we've got the front box, but it goes back by 0.9 meters, 9 centimeters, 0.9 meters. So basically, we want that front screen 0.9 meters worth. So all we're going to do is take that figure, and we're going to times it by 0.9 meters. I'll just check my calculator. It does indeed give you 1.782. We were working in meters still, which we've got. We've now got cubic meters, or meters cubed, which is shown with the number 3. And an easy way to remember that is we've got 3 dimensions. We went along, back, and up. So we've got 3 dimensions. So whereas area we had squared, in volume we've got meters cubed. So all I've done is worked out a flat surface and then found out how far it goes back. The beauty for a nice shape like this is, if we want to, we could instead work out what is this bluey, greeny flat side here. Well, if we look, that is 0.9 meters, and it goes up by 1.1. So we'll do 0.9 times 1.1, which is 0.99. And so we work this one, and we need to find how far it goes back that way. Well, that's 1.8 meters. So if we times that by 1.8, we should get 1.782. If you do that on your screen, you can check. Exactly the same. There should be a cube there. Exactly the same answer. 2 answers the same. And so it doesn't matter which way I work it out. I could have worked out the orange surface at the top and then times it going down. I could have worked out any of the surfaces. It really doesn't matter. So for volume, what I've done here is I worked out the area of flat shape, and then I multiplied it by the 3rd dimension. Whatever that dimension may be, doesn't matter which way around you do it, but that's how we work it. Because a couple of people in the chat have done that. So this formula on top is working out an area of flat shape and then times it by the other dimension. I think is the best and easiest way to work out volume. In effect, all we've done is times those 3 numbers together, but you'll see why it's useful to think about it as a flat shape and then multiply by the 3rd section when I go on. So that was a nice fish tank, square, rectangle, whatever. We're now going to talk about a triangular shape, and we could talk about a tent, something like that. But I like to think of a Toblerone, and I happen to find one at home that is uneaten, which is very surprised. I didn't realise we had one uneaten. So it was the kids, but I've now taken that as mine. So we think of a Toblerone, I'm sure you know a Toblerone packet, the triangle goes back. And I've measured it without eating it. It isn't, I'm trying to promise I haven't eaten any. And it's 4 centimeters across the triangle, and that is both the base and the height of the triangle. And it goes back by 27 centimeters. Again, I'm talking about the triangle and it going back. I don't care whether you call it length, depth, width, whatever it might be. Can anybody quickly in the chat, remind me, and Louise likes Toblerone as well, very good. Can anybody tell me in chat how you would work out the volume, so the area of a triangle? So the first thing I want to work out is what is the area of this flat triangle at the end of a shape? There's a formula you use. Anybody who's on the lunchtime one, it's got to remember because I've got it drilled into them, hopefully. Can anybody remember what that formula was? So you just put the word half, so that's good. There's definitely something we do about half. Half of BH, half BN, Steve's put, but I think he meant H. We'll put it down as a spelling mistake, as a typo. Half BH, brilliant. So the formula for working out the area of this triangle at the end is half BH. As a reminder, that is half base times height. When our triangle is 4 centimeters across and 4 centimeters up, we actually want a half of 4 times 4, which is 16, and half of 16, hopefully you agree, is 8. So the area of our triangle at the end here of the Toblerone is 8 centimeters squared, and the triangle goes back 27 centimeters. So looking at the top, I said work out the area of a flat surface, which we've done, and we're now going to times it by our third dimension, which is 27, which I have got it written down, but I'm going to double check. Always worth checking. It does indeed, same answer. I get 216. We were in centimeters, or stick in centimeters, and remember it's volume, so they're cubic or cubed centimeters. So half base times height for the triangle at the end, and then once I've done that, I then multiply it by the third dimension. So going back to what I said at the start, there is a formula that you can use that does that for you in one go. To me, a much easier way to remember it is you need to know how to work out area of a triangle anyway. So let's work out the area. We know my flat triangle is 8 centimeters squared, and it goes back by 27 centimeters. So we're happy with that. And the third one I'm going to give you then is a cylinder. And I've got a lovely Circo mug that isn't actually mine. I'm not specially enough to receive a branded mug, but there was one on the internet that I took. And I've measured a standard mug, and they're about 8 centimeters by 9 centimeters, we're going to say. Once again, we're going to use this formula that I've got at the top. And the first thing we're going to do is find out the area of a flat shape. Well, let's take the bottom of our cup. The bottom cup is a circle, looks like that. And go on, we'll ask in the chat. Can anybody remind me how to work out the area of a circle? 2 formulas we talked about with circles earlier. And let's see if you remember the one for working out the area of a circle. Does involve radius and pi. There is something else we need to do. Pi is 3.14, which is good. We use this symbol for pi, which stands for 3.14. Our formula, I think that's right, Louise. It's a bit hard to type on here, isn't it? But yeah, that's good. So the formula for working out an area of a circle is pi r squared. One thing you need to bear in mind is we use r is radius, and if we look down here, the diameter of the mug is 8 centimeters. So hopefully you'll agree half of 8 centimeters is 4 centimeters. So I'm doing pi, which is 3.14. You can get it on your calculator as well if you want. 3.14 times 4 squared, which means times 4 and times 4 again. It gives me a figure of 50.24. And hopefully you got the same if you did your calculator. And if we think about it, we've worked out the surface area at the bottom. And I've said we've worked out the surface area, so the area, and then we're multiplying it by the third dimension, and this time it's how far the mug goes up. So we're going to times it by 9. I'm just checking on my calculator. I make that as 452.16. Our measurements were centimeters, and a reminder that because we're talking volume, we're talking about cubic centimeters or centimeters cubed, which is shown with a little 3. I mentioned earlier with squared, where you do a little 2 in the test. If you can't do a little 3, you could write cubed, or you could write cubic meters, centimeters, or you could just put a number 3, and don't worry about it being a small one. They'll understand what you mean. So once again, knowing the formula for circle area, pi r squared, once I work that out, I've got my area, so I just times it by my third dimension. Hopefully everybody's okay with that, and that makes sense. Questions? Can't see any questions so far, so that's good. So those formulas, so the way of working those out, I won't call them formulas because I've not gone into necessarily a detailed formula. I've said work out the area in times by a third dimension. You're expected to know those. If they gave you a more complicated shape, they would tell you how to work out the volume and you would be following the formula that they give you. Similarly, I have said a couple of times that they may give you the formula for these, and if they do, great, forget what you've learned and follow the formula because they've put it in front of you and they made it nice and easy. Same with pi. I said earlier, they may tell you what pi is, and if they don't, use 3.14, but if they give you what pi is, then great, you follow what they say. So volume is relatively straightforward, whether it be cubes, that kind of shape, and you do area of one side times by third dimension, triangle at the end times by how far it goes back, or a circle, work out the area at the bottom, and then times by how high the mug or whatever it might go. We're now going to look at surface area. So that's one measurement. So surface area, as it suggests, is the area of the surface. So I said earlier when we were doing the swimming pool example, I wanted the surface area just at the top of the swimming pool because we just want the top layer. That's the only bit that we can see the surface. But if we've got our fish tank again, all of those sides are surface areas, all of the faces outside. So all we need to do is work out the area of each one and add them all up. So our yellow one would be 1.8 times 1.1 would be the area of our yellow section. Our blue section on the right would be 0.9 times 1.1. And the orange section at the top would be I'm just writing them all over the place, 1.8 times 0.9. We've then worked out the yellow one, an orange one, and the blue one, and then all we need to do is add them together. I won't work through them now because you can do that on your calculator. One thing to bear in mind is obviously this has got the back side of the yellow, the back of the blue, and the back of orange. We'd actually have to double it or add the three together again. So for a surface area for that kind of shape, a cuboid kind of shape, all you need to worry about is working out the area of each surface and add them all together. Bearing in mind there are two, if you think of a dice, there's two sides on each side, isn't there? So should be straightforward. So I'm not going to work through that one because you can work out area yourself and follow that through. Similar for our Toblerone. The one difference I would say here to bear in mind is the surface area. Is when we work out the area of our triangle at the end, obviously it's 4 by 4 and then halved, and we've got the same of that one, so we need two of those. If we think about it though, this shape is actually a square. So all we need to do is 27 by 4 to give us the area of that square. And if you think of my Toblerone that I've still got, there's three sides to it. So I'll be doing the three 27s and then the two ends and adding them together. So all you need to think about practically in the test, and you can draw yourself a little diagram. If you find there isn't a diagram on screen and they've just explained it, if they say there is a fish tank that is 1.8 by 0.9 by 1.1, draw yourself a little diagram of it so you know which surface areas you're doing. And say the Toblerone's a little bit more difficult. It's a little bit different, but no more difficult because you're still just working out surface areas. Unfortunately, our good friends circles, or in this case 3D cylinders, come back into play, and they don't make life as easy for us. So this is a formula that you do need to know and know how to adapt to use it. That is the formula that looks, I think, pretty complicated looking at it. And if you remember what I said before, you don't ever have to write that formula down. They won't say what is the formula, you have to write it, which they might do if you were doing a GCSE. What you do need to know is how am I going to use that formula? So let's think of a nice cylinder, and I moved away from beans or Coca-Cola and we went for some spaghetti hoops. One more could you ask for? I had a tin of tomatoes ready, but I found a better picture of spaghetti hoops to go with. And if we measure a tin, it's about 7 centimetres by 10.5 centimetres is what I've worked it out to be. So thinking of the surface area, if you think about what we're trying to work out, we're working out which parts of that can we see, which parts of that are exposed to the surface. Well, we've got the top circle, we've got the bottom circle, and if we imagine cutting the tin and rolling out, we've sort of got a square kind of shape in the middle. So that's what we need to work out. We need to work out the areas of each of those and then add them together. We know for this top circle and for the bottom circle, it'll be the same. Our formula for working out area, you've already told me, is pi r squared, which is why that's there. And there's a top and a bottom. So this first part of the formula is 2 pi r squareds. So if we do pi r squared in this case, let's put that on. So pi we know is 3.14. Diameter at the bottom is 7 centimetres, so we know our radius is going to be 3.5 centimetres, and we're squaring it, so we do 3.5 again, and I'll definitely have to use the calculator for that one. 3.14 times 3.5 times 3.5, I make that, move this out of the way, as 38.465. And that's for either the bottom or the top. But our formula says we've got two of them, which we have. So we're going to multiply that by 2. And just to make space on the screen, I'm going to erase all of that. And that gives me a figure of 76. I'm going to round it to 93. And we're in centimetres. And we've worked out area so far. So centimetres squared. So hopefully you stayed up with me then. All I did was work out the area of the top of the tin, the area of the bottom of the tin, and sort of added together, or worked out one and multiplied it by 2. So that's a formula we've already seen. We've already seen pi r squared, and we just want 2 of them. So that formula is no more confusing than just saying I worked out the area of the top and the area of the bottom added together. Unfortunately, the way cylinders are, we've got a new formula here, which is an extra one that you do need to remember. And the formula is 2, and it's, I suppose the good thing is it's not much different to what we've seen, but that's also a bad thing because you could easily get confused by the different formulas. But the formula is 2 pi r h. And you've probably guessed we know 2 is 2, pi is pi, and r is the radius. H is the height, in this case, of the tin. So to work this out, we're going to do 2 times 3.14. The radius, we said before, was 3.5. And the height, in this case, we know is 10.5. And if I multiply those all together, I'm going to double check my working. 2 times 3.14 times 3.5 times 10.5 gives me 230.79 centimetres squared. So we now know the area of that top bit and the bottom bit is 76.93. We know the area of the bit in between is 230.97. So all we do is add those two together, which gives me a total of 307.72. Hopefully you went along with that. It was brilliant. I can see a couple of you got the same answer as I was going through, which is really good. So all we need to do once we've got those two figures is add them together. So actually, although it looks particularly confusing, and I do appreciate that on first viewing, the formula at the top does look confusing. This first part we already know. All that's telling us is do pi r squared, area of a cylinder, and times it by 2 because we've got a top and a bottom. The one thing we need to be aware of is this is another formula that we need to learn, is 2 pi r h. But again, as long as you remember the formula, it's not hard to put that into practice and use that. Any questions? I can't see any questions on the chat, so either you've all given up or hopefully that's making sense. As always with these things, I do appreciate that it'll make more sense when you have a chance to have a play with it and do your own questions as well. One thing, I'm just aware of time, but I am going to run through one other thing with you. Not one other thing, really, it's an extension of this. And I just want to show you a practice test question that hopefully you can all see on your screen now. So this is taken from a real practice test, so it's the kind of question you could get in a real test. And the question is that craftsman uses resin to make a paperweight. And the paperweight's this image that's got a square at the bottom and then a hemisphere, half circle at the top. And he wants to basically know how much resin does he need, and what, in effect, what is the volume of those both parts put together. I'm going to take the bottom part first. So the bottom part is a cylinder, and we just said the formula for a cylinder to work out the volume of it. What we're going to do is pi r squared. Can't write that very well on there, I'm afraid. You know, pi is 3.14, and we're timesing it by our radius. You see along the bottom of the diameter is 6, so we're going to times it by 3, and we're going to times it by 3 again, which gives us, 3.14 times 3 times 3 gives us 28.26. And we need then times that by the height, so that's the surface area of the bottom, times it by the height, which is 5, gives us 141.3, and we're working in centimetres, and they're squared. So I've put my information there, and I've put the formula, and I've worked out the bottom part of that, paperweight is 141.3 centimetres squared of resin. We've now got to work out the hemisphere at the top, and the good news here is I said there's certain shapes you don't need to know. So you need to know a cylinder, you need to know a prism, a triangle, and we need to know with cubes and squares. We don't need to remember how to work out the hemisphere, but it's give us the formula at the top. And the formula is 2/3 times pi times radius cubed, which means times radius times radius times radius. So once again, I'm going to work this through all in one go. So I'm going to do 2/3, 2/3. I'm then going to times that by pi, which I'm going to call 3.14, and it's told me on the screen that's what it is. And then I'm going to times it by the radius, which was 3, and 3 again, and 3 again, because I want it cubed. And that gives me a figure of 56.52. So if I know my cylinder at the bottom is 141.3, and I know my hemisphere at the top is 56.52, I can add those together, which gives me a grand total of 198.05. We're actually working centimeters still, and now we've done volume total, so it should be cubed. Sorry, this one should be cubed. That's my fault. I should put centimeters cubed on this one as well. Excuse me. So our total is 198.05 centimeters cubed. I'll just scroll down the screen a little bit, and at the bottom you can see there's a space to put my answer. So going back to test technique, we do need to ensure we actually put the answer in there in the box as well. Obviously, this is on paper rather than a computer screen, and it's even given us the measurements of centimeters cubed. So I haven't got to type that in. So I wanted to go through that for 2 reasons. One, to show you that's how I would work out an answer on a test question. And you'll see, a bit like something I mentioned the other day, I've shown my working. I haven't gone over the top. And in fact, in this one, I haven't even broken it down, but I've shown what I've been trying to work out. So if I have made a mistake, and if I've typed in 4 instead of 3 for the radius, I can show the marker I knew what I meant to do, but my answer was wrong. And I've got my total, and I've entered it at the bottom. And the other reason for showing you this is a good example of where I am expected to know how to work out the cylinder at the bottom, because I've just gone through that with you, and that's a formula you're meant to know, which is pi r squared for the bottom multiplied by the height. I'm not expected to know the volume for the hemisphere, and it's given me on the right hand side here. So all I do is follow the formula they've given me to go through. If I just go back to the presentation. So some things to remember. To work out the volume of a shape, the easiest thing to do is work out the area of one of the sides and then multiply it by the third dimension. If you think about Toblerone, we worked out the triangle at the front and then multiplied it by how far the Toblerone went back. Think of our volume, our cuboid, the fish tank, we could have worked out any of the surface areas and then multiplied by how far we went back and give us the total volume. For surface area, what we're going to do is work out the area of each side and then add them up is the easiest way to do it. Think of the shape you're doing, and if it's a strange shape with 6 different sides, that's fine. Work out all the sides and add all 6 up. One thing to bear in mind is if you are thinking, again, I'll stick back to a Toblerone, you do need the 2 ends as well as the middle bit, or the cylinder we did, the top, bottom, and the right side as well. The surface area is add up all sides. Just make sure you do include all the sides. And the formula you do need to remember for the cylinder surface area is this one, which is pi r squared twice, add 2 pi radius height. The first bit should be a bit easier to remember because all it is the same as area. It's pi r squared, and there's a top and a bottom to our cylinder, to our tin of beans, so we need 2 of them. So this isn't too hard to remember. This is a little bit more difficult, and it's something that you will need to ideally remember along with the other formulas, is you then need to add that to 2 pi rh, which means 2 times pi times the radius times the height. So I did say today that when we were going through these, this would be the harder session, and there is more in here, there's no doubt about it. I will reiterate that if this was in the test, this would be worth 5 or 6 marks, whereas working at the perimeter might only be 1 or 2 marks. So there's more to do, but you do get more reward for it. Hopefully now you know some idea of how to work out volume and surface area of the key shapes. You know some of the formulas to follow, particularly for the cylinder, and we have worked through practice questions together.